the heck? What the heck is that noise? Sounds like an alarm. What the heck? Ooh. Hello? It's locked. Try the windows. Ah! Locked. Gosh. I'm screwed. Try the door again. Go! Oh. I probably got some this to get out. Alright, cool. What do we gotta prove? Triangle ACT is congruent to triangle ART. And then what do we know? Given, let's write that down first. Don't overcomplicate this, guys. It's easier than it looks, right? I've been doing this a long time, but it's still not that hard. That's given, because we already know that. Segment AC is congruent to segment AR, alright? Next one, number 2. First, let's mark that. AC, AR, segment AR, that's congruent. That's why I do give it a little onesie. Segment CT, congruent to segment RT, guys. Don't overcomplicate this, like I already said. This is light work if you know what you're doing, right? That's also given. Let's mark that on the diagram. Always remember to mark your diagram. It'll make your job a whole lot easier, all right? Mark that. All right, what do we got next? We got segment AT. What do we got next? All right, that's too easy. Add a little jelly to it. Segment AT is congruent to segment AT. A psych. Let's get a new marker. I don't like that one. Segment TA. We like that. Give it a threezy. Got a onesie, twosie, threesie. Too easy. That's because of the reflexive property, guys. Alright? Reflexive prop. And us mathematicians don't like to write a lot of words. I'm gonna abbreviate that. Alright. And now look, we're already done. Triangle ACT is congruent to triangle ART, because we got look at this, guys. Look how easy this is, guys. We got a side, we got 2 sides, we got 3 sides. Doesn't look much easier than that, right? Doesn't sound much easier than that, guys. S side, S. Done. Let's go, baby. I heard the click. Let's go.
Meanwhile.
It's an alarm. Gotta get out. Locked. Let's try the windows. Locked. This window is locked. It's locked. What am I gonna do? Maybe I saw this math problem get out. Why not try it, you know? Alright, so we got IT congruent to TC. That is given. We know that. PT is congruent to TA. We know that because of given. It is given. Now, we'll mark the diagram, of course. Now, third. We got vertical angles right here in the middle. So we got angle CTA is congruent to angle PTI. And that is because of vertical angles theorem, or that. And we got triangle PIT is congruent to triangle CAT because of SAS. Ready to click? Let's go, baby.
Meanwhile. die. I want to die doing math. A is congruent to angle T. That's given. Angle P is congruent to angle T. Also given. What do I got to prove? Okay, so we got this. Oh, this is congruent. So next, I gotta prove an angle, or a line. Oh, reflexive. Jelly. It's open now.
Meanwhile.
Well, better get out of here. It's locked. Let's try the windows. Oh, gotta get to Miss Cruz's math class next period. Let me try this. Alright, let's get the given. Angle A congruent to angle D. Given. Segment A, B is congruent to segment DE. And that's also given. Aha, vertical angles. Angle A, C, B is congruent to angle D, C, E because of VAT, vertical angles theorem. And then we got triangle ABC is congruent to triangle DEC because of AAS. See if that opened up the door. We did it.
Gotta see what's making this alarm go off. Bombs? Oh, gotta solve this proof. Alright. So we got start the givens. The segment CE, and that is given. We got mark the diagram. TO, ZE. Alright. Then we got PT, segment PT is congruent to segment CN. PT, ZN is also given. And angle POT and angle ZET are right angles. We also know that because of that is given. Alright, so angle POT is congruent to angle ZET because of all right angles are congruent. Are congruent. That works. And alright, we got triangle P or TOP is congruent to triangle ZEN. That is because HL.
Now that you've seen us stop the bombs using triangle congruence theorems, it's time to tell you which theorems we used. The first theorem we used was called SSS. This means that when three corresponding sides of a triangle are congruent to the corresponding sides of another triangle, it proves them congruent. So this side being congruent to this side being congruent to that side, and this side being congruent to that side proves that triangle A, B, C is congruent. Triangle X, Y, Z. The next theorem we used was called SAS, and SAS is when two corresponding sides and one corresponding angle is congruent, but it has to be in a certain order where it goes side, angle, side, and that's what makes it SAS. The third theorem we used was called AAS, and it states that when two corresponding angles of two triangles and one corresponding side in the order AAS are present, then the two triangles are congruent. The fourth theorem we used was called ASA, and ASA states that when the corresponding angle, side, and angle are congruent in that order, then the triangles are congruent. The final theorem we used is called HL, and HL states that if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent.